This is a re-recording of an Advanced Skywarn training session that was hosted by the National Weather Service on river ice spotters that was held on March 5th, 2025. This was a training course for Maine, New Hampshire, Vermont, and Upstate New York. My name is James Cinco. I'm a meteorologist and hydrology program manager at the National Weather Service office in Caribou, Maine. At the time of this training session on March 5th, I was supported by Senior Service Hydrologist Sarah Jamieson from the National Weather Service office in Gray, Maine, as well as Senior Service Hydrologist John Goff from the National Weather Service office in Burlington, Vermont. We also had hydrologist Abe Farley from the National Weather Service Northeast River Forecast Center located in Norton, Massachusetts. We appreciate all that attended during this virtual session. This is now a re-recording of that session for further training purposes. So let's get started. This training session's main takeaway is the focus on river ice and the dangers it poses to northern communities, especially here in northern New England and upstate New York. We'll go through some background on some terminology and ice processes, a brief review of what the National Weather Service will issue in response to various icing situations, and lastly, we will focus on how you, as a spotter, can help us in reporting the conditions of river ice in your communities. I want to make it clear that we will not be addressing mitigation techniques, as that role is taken by other agencies. From our perspective, our focus is in providing timely information for the protection of life and property. So, what is an ice jam? This video taken here in New York on the Ausable River is kind of a famous video, and it clearly demonstrates the hazards posed by an ice jam. But by definition, an ice jam is a blockage in the river formed by chunks of ice and often suddenly altering the flow of the river. Ice jams cost an estimated $125 million a year in damages across the nation. For the tiny northern towns that ice jams most often affect, it can be devastating. Ice jams are unlike a lot of other threats that we often see with flooding, and these occur in little to no warning. No computer model is able to simulate the growth, breakup, and jamming of ice in a river. This makes it very difficult to predict. And this means the decision makers are unable to proactively take preventative steps. And it is us at the National Weather Service that are unable to provide timely warnings to alert communities of danger if we don't know what is happening on the ground. Spotters. This is huge. This is where spotters can help improve everyone's awareness on the growing threat of ice jams. Real-time reports of river ice conditions and river responses can help alert communities up and downstream. You help fill the role in situational awareness on our rivers and streams in your community. And that is huge in filling the holes of lack of information for us when we need to make decisions and report conditions to local emergency officials. I want to give a shout out to the United States Army Corps of Engineers Cold Region Research and Engineering Laboratory. It is actually located locally here in Hanover, New Hampshire. They are the federal experts on river ice and maintain a database of past ice jam events. The table here shows the number of reported ice jams in their database by state. You can see the numbers are much lower than you would expect for records going back over 100 years. The reason for this is most ice jam flood events actually just go unreported. This is where all of you can come in and help grow this historical record and improve the database. Taking the CRREL data and putting it on a map, you can see how dense the reported ice jams archive is in the Northeast. Furthermore, we can see how well the historical database of ice jams correlates well with the mean January temperatures of below -5 degrees Celsius and the accumulated freezing days over 500. We'll now share with you a few significant historical ice jams from across the region. If you've been in New England for a long time, you've probably heard of the record-breaking floods of 1936. The flooding was the result of an anomalously deep snowpack and three back-to-back storm systems with a lot of rain. The flood resulting from the first storm was accompanied by a breakup in the heavy ice on streams and was distinctively known as an ice flood. The heavy ice cover that had formed over long reaches of streams during the extended period of sub-freezing temperatures in January and February was, in general, thicker and stronger than it would usually found at the time of the spring breakup. Notably, ice jams occurred on the Kennebec, Androscoggin, Connecticut, and other rivers across Maine and New Hampshire. But ice jam floods can occur even without accompanying snowstorms or rainstorms or warm-up events. They can just be as impactful on a local level. Here's some notable ice jams that occurred in Vermont's past. This one on the left is from March of 1964. This was Route 15 in Hardwick, Vermont. That was caused on the Lamoille River. The one on the right is March of 1992 in Montpelier, Vermont. That was on the Winooski River. You can see how much ice and what can happen during those kinds of events. In fact, there is even a minor one currently in the time of this recording on the Passumpsic River in St. Johnsbury, Vermont. That is along Route 5 above Arnold Falls. And it's just more proof of how you need to keep an eye on the ice. Here's some from northern Maine, April 1991 on the left. That's Route 161 in Allagash, Maine. That's caused by the St. John River. That's just past the Dickey Bridge. At the time in 1991, that's what happened. The Dickey Bridge ended up in the river and required a rebuilding of a brand new bridge. On the right, April 1994, Fort Fairfield, Maine. That actually led to the development of flood mitigation techniques for Fort Fairfield. As you can see on the Aroostook River there, it caused a lot of problems and damage in downtown Fort Fairfield. Mother Nature always finds a new way each year to create destruction on rivers. And here's just those examples of how it happens and what historically has happened. We're going to transition now over to the ice processes and learn some terminology, and we'll start with a river ice growth. Ice will develop on a river and then grow down towards the stream bed. We need to become more vigilant when the ice grows at least 4 inches thick, as this can be strong enough to support ice jams. At the National Weather Service, we estimate growth by accumulated freezing degree hours or days, but this method is better suited for a stationary body of water like a lake or a pond. For moving bodies of water like a river or a stream, it will become a little bit more complicated. We won't go into all of the thermodynamic properties here today. We will spare you that level of detail, but just be aware that things like velocity of the water, wind, humidity, cloud cover are all contributed or limited ice growth on rivers and streams. The best way to be prepared is to become familiar with your local history of the first ice date combined with the idea of how much warmer or colder the season has been in freezing degree days should give a reasonable idea of when the ice will start to form. Once water temperatures fall below freezing in moving water, you begin to have supercooled water. This will allow for the development of ice crystals. If it is a slow-moving stationary body, you'll get a sheet of ice. If it is a turbulent flow, you'll often start with frazzle ice. The extent of mixing will impact the type of ice development. In this graphic, you can see the varying types of ice that can develop on the rivers. And now we will go over those types of ice in a little bit more detail and with examples. Frazzle ice. Just think of it as small ice crystals that form in turbulent, flowing, and slightly supercooled water in the rivers, and in moderately windy conditions on lakes and oceans. Frazzle ice in the river grow as ice pieces rub and bump into each other. Now, you don't often have ice jam problems purely from frazzle ice. However, frazzle ice can lock up into larger ice blocks. Kind of think of it as like glue, making the ice stronger. And these are some examples of what frazzle ice looks like. It's usually the first ice you see in the start of the ice growing season. If the water is turbulent or shallow enough, it can push the frazzle ice to the bottom of the river where it can attach to the bottom. This is what we call anchor ice. This ice at the bottom of the river can reduce channel flow capacity, which means it takes less water to reach hazardous levels. Anchor ice is difficult to assess, especially if there is also surface ice present and or snow on top. In places where enough anchor ice can develop, the ice can lift rocks and sediment to the surface through a process called ice rafting. And this is kind of what you can see, the ice through some clearer ice on top, what it looks like down in the bottom in the red circled areas. This is a couple of examples of what we call border ice. The lower water velocities near the shore make it easier for ice to grow. Ice also piles up from upstream locations when encountering the friction of the shoreline, freezing in place and then growing the border ice inward towards the center of the river. Also to note is the long gap between the two ice sheets. This is often referred to as a lead, and it's separated by wind or current. Here's another example of ice. This one is called ice flows. We'll actually play this little video here at the bottom of the screen. This is just large patches of ice that are free floating. It is worth reporting this kind of coverage because across the rivers, if you see it, especially once it gets to the point of greater than 50% of the rivers, we could really use this information in knowing what ice flows look like. The video you see here is actually during a breakup process of ice flows, chunks of ice and large sheets breaking up and flowing down the river. Speaking of sheets, sheet ice or surface ice grows. This is when surface ice grows in place. It is thermally driven and dependent on the river and wind speed. Calm, frigid nights are ideal for growing sheet ice. And you can see in this picture what that looks like. Hummocked ice. Think of this as just jumbled ice. That's another kind of phrase used for hummocked ice. It's just broken piles of ice. There's a bunch of pictures here of what that looks like. Hummock ice, is just ice chunks and ice piled up haphazardly, one piece from another to form an uneven surface. Hummock ice is also quite common along shorelines, especially when flows change. You can leave chunks of ice up on the banks or on the dry areas where the river levels have come down. Hummocked ice is this very jumbled up ice, easiest way to think of it. There's a lot of other characteristics of river ice, and sometimes they're beautiful. Send your pictures of them. We welcome them. We really appreciate pictures of river ice. It's very important for us in understanding the river conditions. These are a couple examples of not often ice, and they're not really related directly to ice jams or floods, but sometimes just cool little ice. The left images are pancake ice, or frazzle pans. This was on the St. John River in northern Maine. You can see the kind of like discs in the frazzle jumped up there. And then on the right was the ice disk that formed on the Presumpscot River in Westbrook, Maine. And it was kind of a famous one. It was quite often there, and it was caused by a little eddy in the river that was naturally occurring. And the ice didn't anchor to either one side of the bank, so it kind of turned into a disk and it just started spinning. So just kind of a couple of cool little different things. Many of you have probably spent a lot of time out on frozen lakes in the winter. You're all familiar with the growth and the breakup of ice, but just be aware that river ice is different than lake ice. There's a lot of reasons why rivers are more problematic. River ice can come and go more rapidly and less predictability than lake ice. There are a number of ice formation processes that are very common on rivers that are not seen on lake ice, like frazzle ice and erosion from currents underneath. We'll talk more in detail on that in a little bit, but think of just lake ice, pond ice is a lot different than river ice. So let's shift our focus now to from ice processes to ice jams, our primary concern with river ice. The unpredictability of an ice jam makes them especially hazardous. As long as the flow arriving above the ice jam is increasing, the ice jam flood threat will increase. Colder temperatures will strengthen the ice jam and cause more upstream flooding, while warmer temperatures will weaken the ice jam and may cause a sudden release of impounded water. It is important for communities up and downstream to be alerted to any ice jam because both sides can flood. Here's a little schematic of a typical ice jam from one bank to the other, looking as if you were in the river, as it blocks the flow of water in the channel. This is kind of what it looks like. You have broken ice chunks glued together by frazzle ice and slush. Midwinter ice jams may freeze in place, causing additional problems later in the season. So this can be a concern for some time. And we've actually had a couple examples this year of mid-season ice jams that freeze in place that may become issues later on. And taking that same ice jam, but looking at it from upstream to downstream perspective. So at the head of the jam is located at the start of the back end of the jam. So the head is the back end of the jam, and this is where water will rise and is most notable. Downstream at the beginning of the ice jam is what we call the toe. That is where we have this diagram here, and you can see how the flow kind of goes under it. And the ice jam is between the head and the toe, and that's how it kind of looks from the side view. And this is actually an actual shot of the same scenario where you can see the head and the toe and the elevated water level. A freeze-up jam. This often occurs early to midwinter. The flow will steadily build upstream until the jam releases, or it is able to gradually kind of work its way around the jam. This kind of happens when you get a real big accumulation of frazzle ice that eventually turns into some thicker pieces, and or you get some broken border ice, and then it will start to block the flow. Here's actually an example of a very recent freeze-up ice jam. This actually occurred this year. In just 3 to 4 days, we saw standard frazzle pancake ice flowing nicely down the Allagash River in Allagash, Maine. And then all of a sudden, then it turned into 1 to 3 foot ice chunks, blocking the river, actually causing the water to rise 6 to 8 feet. Thankfully, this is a remote location and it actually didn't cause any flooding, but sometimes it can. And if you look in the image in the upper left, you'll actually see the United States Geological Survey's river gauge house there. It's a little stone building. And this actually, we noticed a huge water rise, like I said, of 6 to 8 feet when all of this just kind of froze up in just a short amount of time in January of 2025. Now there's 2 main types of breakups, ice jams. The first one is a thermal breakup. This is actually what we prefer. It is less dramatic and less damaging, and it requires a nice gradual melt, causing the ice to, quote, rot. It kind of just rots in place, and it just thermally breaks up that way, and it's nice and gentle. Ice melts from heat, the ice will melt from the heat transfer from the water underneath, and is, and more notably from the solar radiation absorption. So once the snow on top melts off, then the ice starts to rot, thanks to the radiation from the sun. This is the worst right here, mechanical breakups. I'll start this video here. This was a mechanical breakup of 1991 on the St. John River in Allagash. This actually led to the Dickey Bridge being destroyed, the first Dickey Bridge there. Mechanical breakups are often triggered by an increase in flow, which stresses the ice cover, causing cracks, fragmentations, and then eventually movement. These are the most dangerous and the most destructive types of ice jam breakups. And they are often, large ice fragments and can be strong, cold ice, and are often accompanied by a lot more water in the river. And it can become a real serious problem. And like I said, can cause destruction. In fact, this event it destroyed the bridge that this video was actually being filmed on. But it doesn't take a tremendous amount of increased flow to actually break up the ice, especially for smaller rivers and creeks where it doesn't take as much water to raise the water levels. The general rule we use is it takes about 3 times the amount of river ice thickness. That means the water, for example, has to come up 3 times the amount of the river ice thickness to kind of break it up. In an example here, the ice is about 1 foot deep, and it only then needs the river to rise 3 feet for the buoyancy to break up the ice. So 1 foot or so of river ice, the river itself, the water, the natural flowing water underneath, needs to come up 3 feet to kind of break that ice. That's the general rule we use. And for spotting purposes, the most likely areas to find an ice jam are, these kind of common areas. We see, most of the time bridges, bends in the river are very common locations. The upstream end of a solid ice sheet can be a barrier, and it actually is a starting point of an ice jam. There are different places where ice jams typically start to form. Here's a kind of a neat little example off of a very small little brook in Vermont, but it's kind of a great example of an ice jam breaking up. I'll play the video here. You can actually see how, this was a relatively small brook. This is Fletchner Brook in Vermont, and it just all of a sudden breaks loose here. That is what an ice jam, really quickly breaking loose and a lot of water kind of coming down. It's kind of think of it as it's kind of like thinking of it as a dam failure. It's a dam of ice and a lot of water building behind it, and then it just breaks and it rushes down. This is an extreme example on a small, stream brook in Vermont that doesn't necessarily happen on bigger rivers this way, but it can cause a rapid surge of water kind of coming down river. It's a sudden wall of water and that can come rushing down. So you're thinking of flooding going on upstream of the dam, and then when it breaks, you have this wall of water and ice coming down that can also cause a lot of issues. The Weather Service monitors river levels using the USGS stream gauge network. We previously discussed anchor ice and how it can reduce channel capacity. In this simple diagram above, it shows that the anchor ice grows, the river elevation or stage rises even for the same amount of flow. As ice accumulates in the river channel, the stage to flow relationship actually ends up changing. We run into other data limitations, which includes extreme cold. Ice often encases the pipe that the river gauge is measuring, and this kind of leads to this fictitious high stage reading. Radar gauges, like those on some bridges, also have a hard time reading ice surfaces. Additionally, other limitations include batteries that can go low in extreme cold, the batteries that run the gauges. Essentially, they are all reliable. Essentially, they are reliability and quality issues in periods of ice and extreme cold. So this is kind of some of the examples of issues that we can run into with gauges. That being said, a river gauge data can, even though it can be affected by ice, can be helpful in identifying river ice and what is happening on a river. In the example here, we start to see the river gradually rising, and in an otherwise period where it should be steady or declining, this is the first kind of red flag that something is causing the water to back up. The sharp rise is indicative of a jam downstream blocking most of the natural channel. The sudden drop in stage indicates that the jam has broken, likely due to rising pressure behind the jam and then rushing downstream. This would be very similar to that video we saw there from Vermont, kind of like a flash flood scenario. The water then rises again and will likely result in a secondary jam forming further downstream. However, most ice jams go undetected due to the limited coverage of the stream gauge network and spotter reports. We'll focus now on how the National Weather Service operates when we are impacted by ice-covered rivers and the respective products that we issue. As we mentioned earlier, as ice forms, the river channel becomes constricted and therefore the stage to flow relationship is altered, and forecasting the stage accurately is not possible. We will continue to model and send out flow forecasts as the discharge do remain predictable. However, so that our river forecast will have an annotation, we will put that in there, however, and it will just be below the hydrograph, which is when you click on these little squares here. It will indicate that the gauge is being impacted by ice. If there is river flooding as a result of an ice jam, an aerial flood warning will be issued rather than a normal river flood warning. Normally, we issue river flood warnings when it's a natural flow, and then we change to a aerial flood warning or other types of products you'll see in a little bit about when we're dealing with ice jams. To see how this kind of looks in real life, here's an example from the Aroostook River in Washburn, Maine. If the river gauge is ice affected and the recorded stage is not representative of the water flows through the channel, the observation will be ignored and model discharge will be in the forecast shown on the left. If ice breaks free and the stage value is representative of the flow, then the forecast will align with the stage again, and that's the image on the right. As you can see here, the pink trace shows the modeled flows before and after the ice breakup. This is where there was ice impacted and then it broke, and then it's returned to this pink line, purple line, and that is when the ice broke and it's back to normal flow. And that's what it kind of looks like in how when we forecast the river flows. Again, remember, we are forecasting the natural flow and not with ice included. So if ice is present and we are expecting an increase in river flows likely to produce mechanical breakup jams, we won't know the where and how bad necessarily at first, but we will know the risk is elevated. These are often over a large geographic area that we see a threat of possible ice jam flooding. If it is possible, the National Weather Service will issue a flood watch for just one system, one county, a couple areas. But if one river has ice it is likely becoming a regional concern. And when high confidence occurs, we will end up issuing at first a flood watch to give the public and emergency responders and emergency management a heads up that river ice jam flooding threat is possible. So now we go to what we call a flash flood warning, kind of jumping it up real quick. This is where water is expected to come up real fast, flooding is imminent, significant backup of water behind an ice jam, a potential of a larger scale of what we saw in that video from Vermont, and it could impact a community downstream. Sometimes this happens with spotter reports, or a gauge gives us this information that this is about to happen, and we need to issue an immediate product to get people's attention. But not all floods come in a dramatic and rapid speed, and some can just be, but some of these floods can be just as damaging as a flash flood. And for these, we issue what's called a flood warning. This information provided by spotters and boots on the ground drive the way we word these types of flooding. As you can see in some of these examples, these had flood warnings out from what ice and melt did. As mentioned earlier, the National Weather Service will cease issuing standard river flood warnings, and we will issue more what we used to call aerial flood warnings. We will also use standard flood warning products for ongoing flooding from earlier flash floods. Essentially, there was a surprise or rapid rise onset of a flood that has now finally passed, but we're still dealing with flooded areas, including this flooded parking lot, for an example. And so it's still being impacted, and this sometimes we will go from a flash flood warning to a flood warning when there's still that concern. So there's a product that the Weather Service offices in Caribou and Gray, Maine issue that Burlington does not, and this is called a flood advisory. This is typically issued for nuisance ice jam floods, ones that don't reach the level of threat to life or property. These are kind of typically covered by flood advisories. Essentially, these can be used to advise people to avoid a certain area, perhaps a secondary road or a park may be impacted, but it's a minimal impact to the community. Again, National Weather Service in Gray and Caribou issue these flood advisories. Burlington does not for Vermont and upstate New York. These, for an example, a small road that floods every year from an ice jam but threatens nobody, no houses, no lives, it can be used a flood advisory for that kind of example. So now we circle back to the role of the spotter. For those of us at the National Weather Service or at state emergency managements, it can be challenging to receive real-time information that we could have used to try and alert a community when we need to. Your role as an ice spotter is critical to our success and directly tied to your community as well as the downstream communities and upstream communities' safety. So most importantly, I cannot emphasize this enough, please stay off the ice. As an ice spotter, you can get a lot of information from the banks or bridges, safer places. There are state and federal officials that are authorized to go out on ice that do so in a very safe manner and have a lot of safety equipment. But most of us, this is just an extremely unnecessary risk when you can get a lot of information from safe places looking at the ice. In this image here, you can actually see the gentleman is standing on ice that is just sitting there with a giant hole underneath it. It could collapse at any moment, and this person could suffer some serious injuries. That's why we just say do it safely from the safest spots, which is land, bridges, places away from the dangerous ice. And unlike a lake, the river is still moving underneath. You know, it's a moving body of water underneath, and this can easily cause shifts in the ice, which is extremely dangerous. As you can see in all three of those pictures, don't be there. Very dangerous locations. I can't emphasize this enough. We don't want anybody entering flooded roadways. We always say, turn around, don't drown, because a flooded roadway, it doesn't take much water to completely lift your vehicle and move it, especially we're dealing with rivers where even the water is still moving. And then all of a sudden, you also put first responders in a dangerous situation where they have to do cold water rescues to come get you in dangerous situations, and that puts their life at risk. So obviously, as a spotter, don't drive through flooded roadways. Don't go around barricades. They're there for a reason. You can get a lot of information without going around barricades or driving into flooded roads. When going out to spot an ice jam, you know, try to find a site that is elevated so you can see from a good vantage point up and downstream. You can see an example here. This observer was actually on a bridge and was notably wearing a safety vest, which is really important if you have one to have that on. It's bright and yellow or bright and orange or something that reflective so that people can see you. It's also very helpful if you're near a USGS river gauge. Or you can do this, like I said, from the sides of the river on the bankings, but try to avoid the steep bankings. You know, you can do it from a safe part on the banking. And like I said, location, 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 and pictures are always important. Here's some examples of folks spotting the ice, safely observing the river ice. Again, bridges are ideal for the most part until the river gets up too high in some cases. But for the most part, bridges are a pretty good place to be as long as that bridge is open. And you can see from the banking, other photos here of folks from the bankings taking pictures of the ice. You know, it's always good and important to find a nice, safe spot to observe. And we recognize that all river locations are not accessible. And this is where drones have really paid off over the last several years, of the ability to take aerial photos and videos of ice jams. But we want to make sure you're doing it safely. If you have the opportunity to use a drone, please send that information to us at the Weather Service, you know, by pictures and video, or on social media. It'd be great to send that, but always make sure that you are flying your drone legally. Make sure you are following the FAA regulations on the usage of drones. There are a lot of rules and regulations for drones that are regulated under the FAA, so please make sure you know those rules. But drones are incredible, pictures and video from them. So when you're getting your report together and you're getting these details and you want to send it to us, submitting or calling in a report, there are a few key details that we really need. The river or the stream name and the associated town, those are some big things. We have several mill creeks, for example, so we need to make sure we know the correct county and the correct mill creek. Give us a description of the ice coverage and types if possible. For thickness, again, we do not want you to take any unnecessary risk. However, there are ways that you can kind of estimate ice thickness. And if there's any shore ice, you can measure that from a safe distance and not on unstable surfaces. Otherwise, just estimate it. That's kind of important. And pictures, pictures, pictures. Can't emphasize that enough. Here's kind of I'm not expecting you to, report just like this every time, but this is an example of a really perfect ice jam report. It gave a lot of details of the where the jam starts, where the jam ends. It even had some latitude and longitude information. This is an example from out in Ohio. Absolutely a perfect example of an ice jam report, and even had a photograph to kind of go along with it. And make sure when you send pictures to include in the email if we have the permission to use them, because it may be very important for us to put that out also on social media. So if you're sending us pictures and video, please, if you're willing to let us have permission, that's also very important to tell us that we do have that permission. What about an urgent call? What would be an urgent situation? Well, a jam break, that's an urgent situation. If there's flooding going on and if there's been damage, I mean, report it ASAP. Call your respective National Weather Service office spotter lines to report it. If there is flooding immediately happening, you could also, and it is a threat to life and property, please call 911 as well. It should be kind of the first thing you do is call 911 so that warnings can be issued by not just us, but emergency responders can come out. They can put road barricades up and get signs deployed if there is a threat. So please make sure you dial 911 if there's an immediate urgent threat to life and property, and then give us the report as well. That's kind of very important. Again, for any urgent situation, please call our spotter lines. All of this is our way of accessing and getting a hold of us. And, you know, if you are in Maine, New Hampshire, Vermont, or in upstate New York, this is how you can report to us. You can find us on Facebook, Twitter, our email, Twitter X. You can find us on the web for the Burlington reports there, but the spotter lines are all right there. You can call those numbers to get your reports to us. So the main takeaways from this, I just want to say is ice jams may not happen every year, but when they do, they can be more impactful than warm season flooding. Ice jams can be unpredictable, but with more boots on the ground and improved sharing of information, we can collectively together improve our readiness. You know, the river ice reports are key. In fact, it's the only way for us now at the National Weather Service to know what's truly happening out there. But as spotters, please, safety first. While this information is extremely valuable, it must be always collected in a safe manner. I want to say spotters reduce the risk to life and property. That has been a proven fact, and the Skywarn network has done just that. So I appreciate you watching this video and being a spotter or willing to sign up to be a spotter. It's a huge part of the process of protecting life and property. And if there are any questions, please feel free to reach out to our email addresses here. At the time of this presentation, again, it was Sarah Jamieson, the Senior Service Hydrologist at the National Weather Service in Gray, Maine. John Goff, the Senior Service Hydrologist at the National Weather Service in Burlington, Vermont. And then myself, James Cinco, I'm a meteorologist and the Hydrology Program Manager here at the National Weather Service in Caribou, Maine. And Abe Farley, who's a hydrologist at the National Weather Service's Northeast River Forecast Center down in Norton, Massachusetts. If you have any questions, comments, or concerns, please reach out to us or the office's contacts. And I thank you very much for watching this video.